Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 97 of the Network Plus Prepcast, we focus on common network-connected devices beyond traditional computers and servers. Today's networks support a wide variety of endpoints, from voice phones to printers and even environmental controls. These devices rely on reliable network access to function properly and play an important role in both communication and daily operations. Although they may seem peripheral compared to core infrastructure components, their proper configuration, management, and integration are essential. The certification exam frequently includes questions related to their connectivity, addressing, and troubleshooting behaviors. Understanding how these devices operate on a network is not just a matter of convenience. It's fundamental to supporting real-world enterprise environments. VoIP phones, network printers, and IP-based control systems all consume IP addresses, generate traffic, and depend on core services such as DHCP and domain name system. They can introduce complexity into bandwidth planning, quality of service policies, and security enforcement. Their unique needs and behaviors make them relevant in exam scenarios related to addressing schemes, traffic segmentation, or device monitoring within business networks. Voice-over IP phones convert audio into data packets and transmit them across the network like any other IP-based device. Instead of using a dedicated phone line, they rely on Ethernet or Wi-Fi to communicate with a central voice server. This conversion enables flexible and scalable voice communications, but it also creates dependencies on network health and performance. Each VoIP phone must have an IP address, connect to a call management server, and participate in signaling and media exchange protocols to operate correctly. This has to make it. To perform reliably, VoIP phones require specific network conditions. One common configuration is to place voice traffic on a dedicated VLAN, which helps isolate it from regular data traffic and simplifies quality of service implementation. Most phones also rely on Power over Ethernet, or PoE, to receive electrical power directly from the switch. This eliminates the need for separate power supplies. Additionally, the network path to the voice server must have low latency and minimal jitter to maintain clear, uninterrupted communication. These requirements may appear in exam questions about network planning and configuration. Configuring a VoIP phone involves more than just plugging it in. Each device is typically assigned an extension and an IP address, either through dynamic host configuration or a static reservation. The phone must register with a call server using signaling protocols such as Session Initiation Protocol or H.323. This registration process allows the device to place and receive calls, retrieve user settings, and participate in features like voicemail or call forward. The exam may test your understanding of how these protocols operate and how phones communicate within a voice network. Printers also function as networked devices and can be connected directly using an IP address or through a shared printing service managed by a central server. Direct IP printing allows workstations to communicate with the printer independently, while shared printing centralizes queue management and user access. Either method allows for remote job submission and monitoring. Understanding how printers connect and are managed over the network helps with troubleshooting connectivity, print failures, and access control issues. When configuring network printers, administrators can assign either static IP addresses or use DHCP with reservations to ensure consistent identification. Print protocols such as Line Printer Daemon Internet Printing Protocol or Server Message Block may be selected depending on compatibility. Access control is often enforced using network-based rules to restrict who can send jobs to a given printer. These options must be carefully considered during deployment to avoid configuration errors or unauthorized use. The exam may ask you to identify which print method or configuration is most appropriate in a given environment. Printers often include built-in management interfaces to simplify administration. Most modern models offer a web-based console where administrators can view queue status, monitor ink or toner levels, and change network settings. In enterprise environments, simple network management protocol is frequently used to collect performance data, receive alerts, and track availability. Firmware can be updated through the same interfaces, which allows administrators to ensure compatibility and patch security vulnerabilities. For the exam, understanding how to manage and monitor networked printers is part of supporting general network health. Beyond phones and printers, many networks include control devices that are also IP-enabled. Examples include surveillance cameras, environmental systems such as heating and air conditioning units, and door access controllers. These devices are typically configured with IP addresses and accessed through web interfaces or specialized software. While they may not generate high traffic volumes, their functions are often mission-critical and must be secured accordingly. Recognizing these devices and their behaviors is key to managing diverse endpoint environments. Device discovery and registration is the process by which these endpoints obtain their IP addresses and become visible within the network. Most rely on DHCP to receive addressing information, and some may use domain name system registration to appear in internal name resolution systems. In certain environments, multicast discovery protocols like multicast DNS or service location protocol help identify devices automatically. Many endpoints also register with a centralized management system to streamline configuration and ensure compliance. This process is common in large-scale deployments where manual configuration would be impractical. Supporting network-connected devices requires more than just initial setup. It includes ongoing maintenance to ensure functionality and security. Firmware updates may be released by vendors to fix bugs, patch vulnerabilities, or add features. Applying these updates can prevent exploitation and improve compatibility. Security patching is especially important for devices exposed to public networks or accessible over wireless connections. Network segmentation is often used to place these devices into dedicated VLANs, limiting their ability to interact with sensitive systems and reducing risk in the event of compromise. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. One of the most effective ways to manage traffic and security for connected devices is through VLAN assignment. Separating devices by function, such as placing VoIP phones on a voice VLAN and printers on a dedicated print VLAN, makes it easier to apply tailored policies. These separations simplify quality of service configuration, streamline firewall rules, and isolate devices from general user traffic. VLAN segmentation also allows security measures to be adjusted for specific device groups, reducing the overall attack surface and improving control across different types of endpoints. Bandwidth usage is another key concern when managing network-connected devices. VoIP phones benefit from voice compression codecs that reduce the size of transmitted audio without compromising clarity. This helps preserve bandwidth across congested segments. For printers, bandwidth control may include restricting large print jobs or limiting access to high zoom output devices. Surveillance cameras and other video systems should be monitored for resolution and frame rate settings as these impact bandwidth significantly. Implementing controls to manage this usage helps maintain overall network performance and is a common consideration in infrastructure planning. IP address management becomes more complex as additional devices are connected. Administrators must choose between static addressing and dynamic assignment using DHCP. Devices like printers and VoIP phones often benefit from DHCP reservations, which ensure they always receive the same address while allowing centralized control. Naming conventions also help identify devices quickly in large environments. Using standardized formats, such as including location, device type, or department, makes it easier to search for and manage networked equipment. Understanding how to apply these strategies is a key exam topic. Troubleshooting issues with connected devices requires awareness of their specific behaviors. Common problems include IP address conflicts, where two devices are assigned the same address, and unreachable devices, which may indicate network segmentation or configuration errors. Misconfigured settings, such as incorrect gateway addresses or missing DNS entries, can also lead to connectivity problems. Tools like ping, base to root, and device management interfaces help isolate faults. Knowing how to systematically approach these problems and apply diagnostic tools will help you identify and resolve device-level issues efficiently. Authentication is essential for securing networked endpoints. Some devices support MAC address filtering, allowing only predefined hardware addresses to connect. Others, like VoIP phones, may require certificate-based authentication to validate the device with a central server. Centralized access policies can enforce authentication rules across the network using technologies like Radius or 802.1x. These controls ensure that only authorized devices are permitted to access network services. The exam may test your knowledge of these security features and how they are applied to manage device access. Remote management is another common capability in network devices. Many endpoints offer web-based interfaces or dedicated client software for configuration and diagnostics. Administrators can remotely reboot devices, update firmware, or check operational status without needing physical access. This is especially useful for dispersed environments or restricted access locations. Remote management tools also often include logging and alerting features to help detect problems early. Understanding how to access and use these interfaces is important for maintaining a healthy and secure device ecosystem. Monitoring the operational status of network devices can be achieved through a variety of tools. Simple Network Management Protocol is a widely used protocol that allows administrators to poll devices for status information or receive unsolicited alerts. These can include error messages, usage statistics, or warnings about performance degradation. Alerts can be configured to trigger when specific thresholds are met, such as print queue overload or camera disconnect. Integrating this data into centralized monitoring systems provides real-time visibility and supports proactive maintenance strategies that reduce downtime. The role of network-connected devices extends far beyond their individual function. They integrate into the broader IT environment, rely on network infrastructure to operate, and must be managed for performance, security, and availability. From ensuring voice quality in VoIP calls to controlling access through door systems, these endpoints influence the user experience and the overall effectiveness of the network. The exam emphasizes your ability to understand how these devices interact with switches, routers, and other core components, and how their presence shapes policy and planning. To recap, network devices such as VoIP phones, printers, and control systems are vital elements in enterprise environments. They depend on proper configuration, consistent addressing, and secure authentication to function reliably. Their roles often involve integration with servers, call managers, or centralized monitoring tools, and they must be supported with bandwidth controls, VLAN assignments, and remote management capabilities. Recognizing their behaviors, needs, and troubleshooting procedures will help you both in the exam and in real-world network operations. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.